Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. So as you see in my slide here, my name is Muhammad Irfan bin Chirani. I'm from Math 1 and I'm from program PPSMP 2023 until 2028. So today I will talk about the beauty of mathematics, which is from the application of mathematics in computer science or natural science, which is based on my writing test with my two other friends, which is in group. We have chosen two application mathematics about computer science or natural science or whatever. So let's see what I have prepared for the next slide. Alright, for the content here, we're gonna talk about the beauty of mathematics in linear algebra and the beauty of mathematics in statistics. And so based on this thing, we have chosen two applications, which is, as you guys can see, linear algebra and statistics. Because for me, I think linear algebra and statistics are very interesting and exciting to learn about. So let's move on, shall we? Alright, everybody. So in this third slide, we're going to talk about the beauty of mathematics in linear algebra first, and about the statistics, we're going to talk about it later. Let's first understand about linear algebra based on my task writing one, which is I have written with my friends, rather two friends in my continuous assessment. So let's see about this first. Linear algebra is related to mathematical structure and is the study of the properties of linear transformations and combinations. Various topics covered by linear algebra such as linear equations, matrices, determinant operations, rational expressions, vector spaces, coordinates for rectangles, ratios, radicals, factoring, exponents, quadratic or cubic equations, and polynomials, which is from 2022. So based on these sentences, we can learn about coordinates for rectangles from a linear algebra, which is really useful when we know about when there's a point on the rectangle, we want to know the exact location of that point. And also about vector spaces, we want to know where exactly the object is moving and what is the direction of it moving. So let's move on. The form of the formula is formed using linear algebra, which is often used for scientific calculations as well as numerical programs. Algorithms that work with mathematical objects and produce software can also be done with linear algebra in computer applications. In computer applications, algorithms actually take us from the input to the correct output using essentially a set of instructions. Linear algebra has a concept that entirely contains computer science applications such as visual adaptation, can be helped with the concept of exponential relationship. So this is what I have written in my test one with my two friends. So let's move on to the other slide. So this the beauty of the linear algebra first is the first introduction. So we will elaborate more in the next slide, but we're first gonna learn about the introduction first. Linear algebra is a branch of mathematics that deals with vector spaces and linear mappings between these spaces. It forms the foundation for many areas of mathematics and has the numerous applications in fields such as physics, engineering, computer science, and economics. The beauty of linear algebra lies in its elegant structure, powerful techniques, and wide-ranging application. Here are some aspects that illustrate the beauty of linear algebra. So let's learn more about it in the next slide. So here, first here we have the abstract structures. Linear algebra introduced abstract structures such as vector spaces, subspaces, and linear transformation. These structures provide a framework for understanding and analyzing a wide variety of mathematical and real-world phenomena. The abstraction allows for the formulation of general principles and theorems that can be applied across different contexts. That is the first of beauty of linear algebra. We're going to move to the second one here. Geometric interpretation. Linear algebra offers a rich geometric interpretation of mathematical concepts. Vectors can represent points, lines, planes, or higher dimensional objects in space. Linear transformations can visualize expressions that stretch, rotate, or share geometric figures. This geometric intuition enhance our understanding of abstract algebraic concepts and their application. Like I say in this sentence here of the linear algebra offers arithmetic, geometry, and etc. About the vectors can represent point lines, planes, or higher dimensional objects. Like I say, vector is a line, and there's at the end of the line there's like an arrow which is represent the direction of the object or arrow is moving on, and the arrow also can be symbolized as a value of it. It also has a value on how fast it's moving, what is the magnitude of its moving. So let's go to the third one. Matrix representation. Matrices are fundamental objects in linear algebra that encapsulate linear transformation and system of linear equations. The matrix representation facilitates computation and provides a compact way to express complex relationships. Matrices also play a crucial role in solving system equations, performing transformation, and analyzing data through techniques like matrix factorization and eigenvalue decompositions. So let's move on. So this is the first one. So let's move on to the fourth one. So in the fourth one here, we have the theoretical depth. Linear algebra is rich in theoretical depth, which with a wealth of results and theorems that form the basis of more advanced mathematical concepts. Concepts such as eigenvectors, eigenvalues, determinants, and inner products have deep theoretical significance and find applications in diverse areas of mathematics and science. The interplay between abstract concepts and concrete application enriches the subject and fosters deeper insight. So fifth one here, we have computational power. Linear algebra provides powerful computational tools for solving a wide range of problems efficiently. Like I said, linear algebra is used in a lot of field. Example, like the first one we have talked about, which is vectors, um, exponential. We have also have linear equation. We need to solve when there is a lot of question. We need to know the value of x, y, z, which is why is this that's really helpful. For example, what there is in this situation, which is consists of three items, and that those three items have three values, and we need to know the exact value of the three items when there's three equations, which is people buying the items, and it come with different quantity and different prices. That will be really helpful to identify what the price for each of the items. So let's move on to the sixth one here, interdisciplinary applications. Linear algebra finds application in various interdisciplinary fields, demonstrating its versatility and relevance. It is used in physics to describe quantum mechanics and electromagnetism, in engineering for signal processing and control system, in computer science for graphics and optimization, and in economics for modeling economic system and decision making processes. The ability of linear algebra to model and solve complex problems across different domains highlight the beauty and utility. So which is really have a lot of functions, which is really beautiful when we see the some things about stuff when it's like a lot of uses. It's really beautiful about it. So here's let's look at an example a question that I've been writing the test one, the example. For example, like what is really the beauty of it? What is the beauty? Like this is just a question. Let me tell you about it. So here's which is we have like the question now has been to the graph ruler in the following shape, like here, this shape right here. So okay, we can that's exactly gonna ruin all the things. The shape graph equation is 1x to the cube minus 3x to the power of 2 and minus 6x plus 8 equals 0. Find the root of equation for the graph ruler, which is 1x to the power of 3 minus 3x power 10, etc. So what is exactly the point of this equation? What is the beauty of it? Like, for example, when we are doing statistic problem or any problem of solving an area or uh, a volume and a lot of things, we actually have a graph about it. Every problem have graph of it, so we need to solve the graph. For example, this is the graph. When we have this graph, we need to draw of the x line, and also I'm sorry about it, it's a little bit thicker. So we're gonna draw about the line, which we have the y-axis and the x-axis. So what is the function of it? So we need to know which is the root to find the solution for the problem, which is the factors here. The root is the solution of the equation. We have, for example, we have problems about area, volume, or any other stuff, about statistic, more like the rate of things, rate of crashes, accident. We have a graph here. So when it comes to the graph, we have exactly line here. We cannot like put a random value of x or y. We need to find the exact value to find its perfect solution or exactly the right solution for the equation. So to find it, we need to use a formula which is the linear algebra expression, which is really helpful to find the right solution when it's come to find the exact value of x, which it is going to help us a lot in finding the exact value. So I hope you guys understand about it. So we're going to move on. All right, everybody. So today we are going to move on about this slide here, which is the more elaboration or more explanation about our previous slide, which is the previous slide is only contained about the question and a little bit, kind of tiny, a little bit of solution there, which is don't have the exact answer. So here we are. In this slide, I'm gonna teach you, explain you more about explain you about the solution of your question here. So like I said, if I just like leave you guys on that question, like stuck in the middle. We don't know what is the answer, and you guys will be a little bit confused or a little bit frustrated about it because we don't know the exact answer about it. So here we are. We have the question here from the previous slide. So we're gonna have the third step, which is the previous slide only has only two steps. So right here we have another two steps. So this is the three step here, which is execute the plan. So I'm going to explain to you guys about it. So first of all, we have the function here, which is fx. Of course, when we have any equations at all, sorry about the laser pointer, we have like, for example, like cubics, x to the power of cube, x2, we need to equal to any functions. I'm sorry, it's actually f, which is actually fx like here, so don't have this one. So we need to equal any equation to fx. So by me in mathematics, so we can get the value of x or exact value of x. If we just like let the equation be what it is, we're gonna be a little bit confused. We don't know what to do with the equation, so it is really important to equal it to fx or y. So here we are. We're gonna elaborate more about this. So here we have, it says here, make sure equal to 0 when substitute x, which is why it is important. For example, when we have the root of the equations, whatever we do, for example, like I said, any equation which equal to fx, when we want to know the exact value of the equation of x of the equation here, we have the x power of 3 and the power of, I'm sorry, this is the power of 2 here, not 3. We need to equal to 0, so we will know exactly the value of x, but we know multiply it, divide it, whatever we do with it, try and error. Maybe this equation a little bit weird, so I'm just giving an example here, not being serious right now. It's just an example. So we need to when we substitute it and in one of the factors into here, it's gonna be equal to 0 because we, in the first place here, we already equal to 0. So whatever we substitute number into here, it will turn out to be 0 because in the opposite of the equal here, we have 0. Here is same as here. That's why equal to 0. We have to find every root, every value of x to get to 0, which is the solution of the equation. So right here, like I said, we substitute 1 here first, we get the root 1, so we substitute 1 first, which is finally we get the answer 0 here. 1 of the answer because equal to 0, because it is equal to 0, which is already the root. When the equation we put substitute value in it and equal to 0, it is one of the root, the value of x. So now when we have done got to 0, the second step we need to use the division, which not synthetic division method, which to get another root. So right now we use the synthetic division, which is 1 go to down here, and then this one which I have noted to divide to subtract with, we go up here and subtract with the second number here, subtract with 1, and we're going to get -2 and -8. Oh no, it's not subtract, it's plus, I'm sorry, say +1 with -2. So finally we'll have this one. It will turn out into this number, and this number will be turned into equation here, and the power is -1. When you have the power of 3 here, we're going to go power of 2 here, so this is will be, and 1 is the exact first root, and then this one, when we have the power of 2, we can factorize it and we get discussion. Finally, when we factorize it more, put it in the calculator or whatsoever, we finally get this answer here. This is the 3 factor that form this equation, the cubic equation. I hope you guys understand that. So let's move on to the next slide. Let's move on. So here the summarization of the beauty. So in a sense, the beauty of linear algebra lies in its elegant structures, geometric interpretations, theoretical depth, computational power, and interdisciplinary application. Its fundamental concepts and techniques form the backbone of modern mathematics and science, making it an indispensable tool if I understand solving diverse problems. So I hope you guys really understand about linear algebra. I show probably 8 to 7 slides for. So hopefully you guys understand it. So we're gonna move on to the next slide about statistics. So here we go. So let's move on to the next one, as this slide say. So here we are at the beauty of mathematics in statistics. Let's refer to the task one. Other application of mathematics in science computer is the use of statistics, because statistics mainly deal with large number of data. This suits very well with what science computer is about, because programming in science computer need to be deal with a lot of data in just a short amount of time. With statistics, analyzing data becoming way more easier, because it can interpret a lot of data in specified method and make an assumption based on the previous data that was being translated. Some techniques that was used under the statistics scope are such like hypothesis testing, regression analysis, statistical model, and many more, which can be used to display various type of data in a large number with a systematic visualization, and also can make prediction based on that data, which can help improving the accuracy and the efficiency of their algorithms. We take an example of the regression analysis technique, which is about understanding and finding which part is the most important and which can be ignored. So this is what I have written, or my friends have written into our task one. So we're gonna elaborate about the beauty of it, what we didn't understand deeper about it, the beauty of it. So we will truly understand about this thing. So let's move on. So here we are. Let's explore about the beauty of statistics. The previous time we have already learned about linear algebra, and here we are. We're gonna learn about the beauty of statistics. The beauty of mathematics in statistics lies in its ability to uncover patterns, make predictions, and draw meaningful conclusions from data. Statistics as a branch of mathematics provides a rigorous framework for collecting, organizing, analyzing, and interpreting data. Here are several aspects that illustrate the beauty of mathematics in statistics. So before we moving deeper, I'm going to say about statistics is really helpful when we deal with a lot of data. For example, like we are doing businesses, we want to know what our customer likes, what our customer dislikes. So we first make an activity or like a situation when we sell stuff, what is the most popular item, what is the least popular item, and we'll make data about it, and about the popularity of the items, how much people came to the store based on the days, and etc, etc, etc. These are really important for businesses, and it can be applied to other situation like farmer, export, and etc. This is really important because we need to make an accurate data so we can find the best solution to overcome this problem. So let's move on to the beauty of it. So here we have the beauty of the statistics. So the first one is about the probability theory. Probability theory, a fundamental branch of mathematics, forms the basis of statistical inference and decision making under uncertainty. It provides a formal framework for quantifying uncertainty and reasoning about random events. The beauty of probability theory lies in its elegant axioms and theorems such as Bayes' theorem and the law of large numbers and the central limit theorem, which is here the central limit theorem, which I learned in the previous sem. Really interesting to find the value of it, the value of the graph, of the data that we collect from our activity or situation that we have made, which have wide-ranging application in statistics. Of course, like these three are really main important things in statistics that I've learned about basic. It's only about basic statistics, and statistics has a lot of more things. Really beauty about statistics. So the second one we're going to learn about is data visualization. Statistics offers powerful techniques for visualizing data in meaningful ways. Graphical methods such as histograms, scatter plots, box plot, and probability distributions allow us to explore patterns, relationships, and trends in data. The beauty of data visualization lies in its ability to convey complex information intuitively and visual insight into the underlying structure of the data. What statistics, so I'm going to elaborate about this. What statistics has done is like when we are doing situation like I've said a lot of the time for when we do a situation, it's gonna be like a lot of data we need to deal with, like about project, about customer, about the days, about discount we need to do, so our solution problem. This is based on the business situation out here. So what statistics do is like it's arranged data, make it a little bit more easier to deal with, so we will not be like a little bit troubles to deal with. We're gonna be have a little bit easier time to deal with it, so we're gonna save a lot of time. Our burden is a little bit lightened and etc. more. So let's move on to the third one, which is descriptive statistics. Descriptive statistics involve summarizing and uh, describing the essential features of a dataset. Measures such as mean, median, mode, variance, and standard deviation provide concise summaries of data distribution. The beauty of descriptive statistics lies in its ability to distill large amounts of data into manageable summary that capture key characteristics and trends. Like I said, uh, statistics really take all the data which is really spread it around it, and it takes one by one and arrange it to its group so we can deal with it a little bit easier. So let's move on to the next slide. So here we have inferential statistics. Inferential statistics allow us to draw conclusions or make predictions about a population based on a sample data. It encompasses techniques such as hypothesis testing, confidence intervals, and regression analysis. The beauty of inferential statistics lies in its ability to leverage sample data to make inference about the broader population while quantifying the uncertainty associated with these estimates. Like I said, when we are dealing with data, for example, we're gonna take a very different example here, like a sports. We wanna interview like a city about what is their favorite sport. We cannot deal with like a million of people, 1,000 people, 100,000 people. We're gonna deal with that. We don't have a lot of much time to deal with that. It's gonna take like about a month, 2 months. It's gonna be a long time. So to make it easier, we're gonna use inferential data statistic, which is gonna take like a sample of it, like 200, 300 people to like to be the representer as for the whole city, so it will make us our job a little bit easier because 200 people is enough to make a conclusion about the people in the city, although it's not maybe accurate, but at least it kind of almost accurate, like 0.7% accurate. We are humans, so we always cannot be perfect, like as the saying goes. So the fifth one we're going to talk about here is statistical modeling. Statistical modeling involves formulating mathematical models that describe the relationship between variables in the data set. Models range from simple linear regression to complex multivariate models. The beauty of statistical modeling lies in its ability to capture the underlying structure of data, identifying which is underlying such as identify patterns and make prediction about future observation, which is when we graph the data about statistic, we can like predict what will happen. It will have us to prepare for what will happen in the near future. So when we prepare, we can handle the problems easier. Like for example, our business is going to be corrupted if we keep doing exactly the same thing for a bunch of years. So what is the conclusion? What's the effect? So we already knew what's the effect. So we will get ready for it, and we will be prepared to to overcome the problems. So sixth one here we're going to talk about is the probability distributions. Probability distributions plays a central role in statistics, representing the likelihood of different outcome in random processes. The beauty of probability distribution lies in their mathematical elegance and versatility. Common distributions such as normal distributions, binary distribution, and exponential distribution have well-defined and find widespread applications in modeling real-world phenomena. About the probability distributions here, well, it actually have three sub distribution: the small y, which is the normal distribution, binomial distribution, and exponential distribution, which is these the three main components that help for probability distribution that will make our problems a little bit easier. So let's move on to the next one. So the seventh one here, the final one, we're gonna talk about the Bayesian statistic, which I've not learned about, but I have explored it in a website, journal, and a lot more. Bayesian statistic is a framework for incorporating prior knowledge and updating beliefs in light of new evidence. It provides a coherent approach to statistical inference based on Bayes' theorem, like when we learn about. So we're gonna before we moving on. I'm going to talk about Bayes' theorem, which is really helpful when there's like situations of of probability being a little bit more complicated. The Bayes theorem is kind of a little bit complex formula and more, but it's really helpful when it comes to certain situation. So let's move on. The beauty of Bayesian statistics lies in its principal treatment of uncertainty, its flexibility in handling complex models, and its ability to incorporate subjective judgments into the analysis. So here we are. We have the summarization of the beauty. Overall, the beauty of mathematics in statistics lies in its ability to transform raw data into actionable insights, uncovering hidden patterns, making accurate predictions, and informing decision making and in diverse fields such as science, engineering, economics, and social science. It exemplifies the elegance of power of mathematical reasoning applied to the analysis of real-world data. So, of course, in the real world, we have a lot of data to deal with. The government, when we are in the government job as the teachers, as the businessman, we have a lot of data to make. Like for example, when we become teacher, for example, first example, um, we have need to know what our students are capable of. So we have a lot of students, we have a lot of classes, so we need to divide it into the groups. The smartest one, the middle one, and the lowest one, which is lowest in the intelligence. So when we divide it into the three groups, we can handle it easier. So what, for example, what we need to do with intelligence one, what we can do with them to be them to move on and become smarter, and the middle one to be like push them a little bit more to the intelligence one to keep them in the balance, but don't want them to like fall down into the lowest group. And the lowest group, what we need to do with them, like we need to make them become more smarter, make them a little bit more hard work, so they will become achieve slowly from the lowest one to the middle class and the highest class, which is really when helpful when we use statistic in it. Like we can arrange our data problems a little bit more neatly, I say like that. So let's move on. So that's all for me that I've started today for the beauty of mathematics. Hope you guys enjoyed my presentation today. So thank you for your time for my presentation, and I hope you guys understand it a lot about statistics, linear algebra, and etc. I hope you guys learn a lot about it, and maybe maybe apply it for your future projects and more. And I hope you guys enjoy my presentation. That's all from me. I'm Muhammad Ifami Chirani from Mathematics 1 program PISMP June 2022-23 until 2028. That's all for me. I hope you guys enjoy. Thank you very much.